So we have today, we'll spend the whole day till tonight. So during the course, don't hesitate to ask. If you have any problems, any questions, if I can give you an answer, I will give it to you. So don't hesitate, no problem. Okay, the idea is for today, first we start with the practical part because always need some time for the firing process. And then we interrupt and doing some lecturing, and so that's the way how we do it. So the plan is in the morning we want to do ceramic, in the afternoon we want to do the signal light curing material. That's the idea for today, so I hope you enjoy it, and as I said, don't hesitate to ask. I'll try to give you an answer if I can. Well, I'm coming from cold Germany. At the moment, now it's getting spring in Germany as well, but I'm living close to Munich. Maybe you heard about this October beer festival. Maybe in India it's not so popular, but in Germany it's a huge, how to say, a huge ferry or whatever. And a lot of people are there, so I'm living close to Munich. This is my family. It's my son, he's an engineer at a BMW. My daughter also is working for the electromobility, and on the right side is my boss. Well, that's our family. Okay, so let's start. First I want to introduce a little bit about our company. Our company was founded nearly 100 years ago, so we have a very, very long tradition in producing for the dental technicians as well for the dentists. So we have the full range, whatever it's necessary, it's needed in our business. So let's start. As you can see, this is, we call it, we have families, you know, these are kind of families within the, can you ask again, please?
The late
air conditioner. Yeah. We have this Heraceram, this includes all ceramic systems. We have ceramic system for metal, we have ceramic system for lithium disilicate or EMAX, I don't know how you call it in India. We have for zirconia, and of course we have pressed ceramic, and we have also this monoceramic, but I think it's not so popular in India, monoceramic, isn't it? No. It was developed especially for the Chinese market, but it's really not, there's no need at the moment. So we will cancel it, I think, in the next few years. Then we have this called Pala family. That means all acrylic stuff, artificial teeth, all kind of acrylics for full denture, for RPTs, for whatever. On the third part you can see this called Hera. This is all the metal. We are producing all kinds of metal, non-precious and precious metal. At the moment, I think all over the world, the amount of precious metal is going down because 1 gram of gold is very, very expensive. So I think the most markets are changing to the non-precious. And on the fourth, we have the signum, what we want to do in the afternoon. It's a light curing material, and the picture's not very good, sorry, it's on the beam a little bit. We have this means Cara, that means all the milling stuff. Laser melting, milling, scanning, all the digital things which will come up in the future, in the next I don't know, next years, whatever. So you can see this is only for dental technicians. Today we are talking about the dental technician. For the dentists as well, we have all the impression material and the filling material, but it's not our topic for today. So you see we can offer everything, and in future our guys in India, they try to do a big effort to bring it in the market, to support you, to give you help, whatever. Okay, so let's talk about ceramic today. We offer mainly 2 systems. The layering system, I come up to that later, the layering, the color layering system is the same. For the red one is the metal ceramic, and the green one is for zirconia. And for signum we have the same layering system. So it's very easy. If you have in your mind a system, then you can use it for all kinds of material, whatever. So the red one, as I said, is for metal, the red lids, and the greens for zirconia. What do you think? Why we need 2 different materials? Have you any idea?
Low fusing?
Huh?
Low fusing?
Yes, low fusing, but it's another story. You're right, but what do you think? Why we can put...
CTE?
Right, that's the point. That's the problem. The CTE of metal is different compared to the CTE of zirconia. But the CTE, everybody knows CTE?
Official note.
Don't hesitate to ask. That means the extension of the materials and the shrinkage. And so the CTE of zirconium dioxide and lithium disilicate is very, very close. The one is 10.5, the other is 10.2, so they are very close. That means we have for both materials, lithium disilicate and zirconia, only one ceramic system. The point was, Ivoclar had a patent till 2015, I think. That was the problem at that time, but now since about nearly 4 years, it's allowed to offer the same products. So we have this, always the green lids can be used for both systems. And the firing temperature, that's why it's written normally 750 degrees. You're right, it's low fusing material. Even our metal ceramic is nearly 100 degrees lower than the others. I don't know which material you're working at the moment, like Vita, Ivoclar, or whatever you're
Mostly
working. Ivoclar. Okay. Emax. Oh, okay. So it's a little bit higher. Our material, our firing temperature is a little bit lower. And the advantage of our material as well is the firing, the heat rate is much faster. We can heat 100 degrees per minute. So we save a lot of time. A normal firing lasts about 10 minutes roundabout. Good. First of all, I want to give you some ideas about the practical things, the preheating. When you put all kinds of ceramic, opaque, pre-opaque, NP-primer, I'll come up to that later, all the ceramic systems, everything is mixed up with liquids. All liquids which are in the paste evaporizes. That means the liquid has nothing to do with the product itself. Only the ceramic powder is what you get out later after firing. Everything is evaporizing. The only thing is, if you're using water or liquid, modeling liquid or whatever, it's the time, how fast it evaporizes. So, but for modeling, it has no influence on the how to say, on the appearance. A little bit, yes, because if you have some very, very high viscous material, the space between the cones is a little bit bigger, then it can be shrinkage a little bit more. But normally all liquids has to evaporize. That means, especially if you have pre-mixed materials like paste opaque or whatever, they has to be produced with a special kind of glycerin. That takes more time to evaporize than normal water, for example. That's why, if you have problems with bubbles or whatever, extend the preheating time. Because all the liquids start boiling 100, 120 degrees roundabout, and if you put the pre-mixed material in a very hot furnace, let's say you have done a firing, the furnace is coming down, it's still 600, 700 degrees, and you put the grounds in, then it starts boiling on the surface, and then you get bubbles. So that's very important, pre-drying, for the wetting, for the connection between opaque and between metal or zirconia or whatever. Good. Well, give you a little bit of idea about the product, of our product. As I told you, we have a very, very long tradition in our business. And we are producing since nearly 80 years artificial glass, and mainly not for the dental business. The original idea was for the industry. If you can see on the right side the fibers like that, one fiber has a thickness of a hair, like this. And the quality of this glass is really very, very good, because these fibers has a length of about 5,000 kilometers. You can imagine it's a long distance. All telephone calls between Europe, Asia, and Europe, America are going through one of these fibers, only one. All telephone calls, I don't know how many million per day. It's only one fiber. The isolation is like that, but the fiber itself is nearly like a hair. Also, you can see we know how to do glass quality, because it's nothing than an optical wire. And the same material which is used, therefore, we are using for our ceramic. today the ceramic is artificial glass. It has, on exactly spoken, it has nothing to do with ceramic. It's artificial glass with oxides inside. That's why you get a color. So you see, we have a little bit experience about the material, and you will see the quality of the glass we have compared to other companies. It's different. Yeah, as you can see, the quality of the glass I show you later in the original. So what we are doing, I don't know if there are coming some more guys.
Yeah, the people are coming. Within
how long it will take?
15-20 minutes.
30.
15-20 minutes.
15 to 20 minutes.
So because the idea is now to do the pre-opaque or the NP primer, and then during the filing process we go on. Okay, anyway, we can't wait for all of them. So what we are doing now to save time, because we are a little bit short in time today, so we do put NP primer. Everybody will get a model and one ground. That's the job what you have to do in the morning. Can you deliver the models, please, and the grounds? And we put this NP primer. I'll explain you later why we do that. But to save time, first just do it like I show, and then I'll explain why we do it, okay? We need a little bit to press the time. So we are a small group. I think it makes it more easy if you come to my table and have a look how I do it, and then you do it. And then, yes.
Yes.
Everybody has some tools. You have some tools, and
Yes.
brushes and things like
Yeah,
that.
they have with them.
Good. So let's start. I'll show you, and then we go on with the lecture. It has to be a very, very thin layer all over. That's yeah. We prepared. They were made by SLM. You know SLM, selective laser melting. And everybody will get a crown like that. Where is my hard copy somewhere? There's a booklet.
Booklets in there.
Booklet. I'll explain later what I do. So this is what we're doing now. A very, very thin layer, no lux. Only. It's a chemical stuff. It only prevents to producing too many oxides. Sometimes, do you have any problems in the lab with bubbles or cracks?
कई बारी bubbles की problem आती है ना, तो उसको avoid करने के लिए.
I will explain you later why and how you can avoid this problem by this material. It's just a solution. It's not a must. It's a solution if you have problems. Of course, we have also in the plane. It's also pre-opaque. This is a little bit more expensive, but it solves all the problems. You have to calculate. Okay, it costs a little bit more. I don't know in India. I have no idea. But if you have to do a crown or bridge twice, you have to calculate how much does it cost, or if you spend a few rupees and to be on the safe side.
2 ml.
Yeah, it's about
2 ml.
2 ml. It's about. I think you can make 100 crowns.
ये खाली मतलब it's not compulsory, must नहीं है ये.
Opaque bonding का.
पर ये लगाओगे तो
ये लगाओगे तो जैसे bubbles की problem आती है, oxidation की होती है, तो उसको solve करना है. मतलब कई लोग थोड़ा हल्का metal use करते हैं, तो उसके लिए.
It's a pure chemical stuff.
कुलजर का ही है.
कुलजर
किस नाम से?
कुलजर हेरेनियम Na.
अच्छा हेरेनियम.
But you can use it for all metals.
आप use सब पे कर सकते हो, लेकिन ये it's not a compulsion.
All
जरूरी नहीं है.
non-precious metal, not precious.
Non-precious.
Okay, that's it. Can I have a look at it? That's it, like this. And after firing, it looks like this. It's chemical. It has nothing to do with color.
Very thin layer.
Very, very thin
Very
layer
thin.
to save money.
Money is must. It's must.
I know. I'm a dental technician. I know.
We are here for money.
We are selling. I like if you choose a whole bottle. It's okay now.
हमको ओपेक वेल्डिंग के लिए सही रहेगा, ओपेक वेल्डिंग सही होगा।
So this is
बस जस्ट कि मेटल को आप कवर कर रहे हो, मास्किंग कर रहे हो उसको।
हाँ मेटल कवर होगा फिर तो वेल्डिंग सही होगा।
मास्किंग नहीं है
नहीं
मतलब कि उसको बबल्स के प्रिवेंट कैसे?
बेसिकली ऑक्साइड्स की प्रिवेंशन के लिए जैसे
I
जब आप
explain.
हीटिंग एंड देन पीटर हैज अ वेरी गुड एक्सप्लेनेशन एक्चुअली।
सेम प्रोग्राम पे डालना है जो ऑक्सीडेशन का है 980
950 1 minute.
980.
And it's not
950.
950. And it's not necessary to make an oxide firing before. That saves time as well. Normally, your oxide firing takes I don't know, 20 minutes.
Too much time.
Too much time. If you're using this, it's not necessary. You can put it like I did, put it immediately in the furnace, and you save one firing process.
So after sandblasting, we apply that and
Sandblasting, steam cleaning,
Okay.
make it clean, and then you can apply that. Put it in the furnace 950, 1 minute.
So no required oxide padding.
Now I think everybody will do that.
Okay.
And then we put it on the tray and do the firing. Then I go on with the explanation. So everybody will get models and the
मॉडल्स आपने अपने आप ले लीजिए, अपनी सीट पे रख
and yes,
नंबरिंग सर नंबरिंग डाल दो और नाम लिख दो यार, मार्कर है मार्कर पे नाम
मॉडल पे
क्राउन होल्डर।
नहीं एक्चुअली में तो फाइलिंग रहती है ना मॉडल तो इसके लिए ऐसे सर्कल बना के
test. We made like coins with about 2 centimeter diameter. We made only the glaze material from each company. This is ours, this is GZ, this is IPS, IMAX, and this is Croatian. Croatian is also known in your country?
Yeah.
No.
Yes, not much actually, but it is there in patches only.
What I want to tell you, the most transparent material everybody has in their set is the glaze. So we took the glaze material from every company. According to the using instruction, we did the firing. We made a coin like that size, and normally the glaze material should be transparent. You can see by yourself what we did. This should be transparent. This should be transparent. This should be transparent. Look at this. Is this transparent? I'm not sure. So you see, this is our material. You can see the quality, the difference of the quality. Normally nobody is doing a coin like that and about 2 millimeters thick. Nobody will do that. It's just to show. But I want to show you the quality of the material. So if this coin is about 2 centimeters diameter and about a thickness of around about 2 millimeters, and we did all the same size, all the same thickness, just to compare, to get an idea about the material. Normally you're doing just a very, very thin layer on the surface by glaze, but this is to demonstrate, to see the quality. I think you can see it by yourself. I don't have to say anything. Okay, coming to the next problem in general. As I said in the morning, the ceramic today is artificial glass. If you have a normal windscreen and you smash it with a hammer or whatever, you smash it in the center somewhere, you get breakage everywhere. The same thing can happen in the mouth. If the patient bites on a fork or whatever, also chipping or cracks or whatever can occur. So the idea is to put something in to stop these cracks. This material is called lucite. Lucites are small cones which are mixed in the ceramic material, in the powder. It's a mixture of glass, lucites and oxides. Oxides are giving the color, lucites stop the cracks, and the matrix is made by artificial glass. The problem or the disadvantage is, these black guys, this is the lucites. We made it only for the photography. Normally they are transparent, but just to take the photo, we made them black. And this is our crack here, this one. So these are in here to stop or deviate the cracks, not get the problem of the chipping. The problem, we talked in the morning about the CTE. The point is, these lucites have a very, very high CTE. The CTE of our ceramic is the mixture of the matrix plus the lucites. The lucites have a CTE of about 25. Do you know the CTE of your metal? Anybody knows? What you're using your metal? No, the question is, do you know this? Do you know the CTE of your ceramic? No? Okay, I don't know. I would learn. Ours is, it's a range of around about 12 to 14 in this range. 12 to 14 in this range. The lucites, I said they have 25, so it's nearly double. The disadvantage is, after every firing, the amount of lucites is normal growing. That means the more lucites, the higher the CTE. If you get cracks, or mainly cracks after the 4th, 5th, 6th firing, whatever, that depends on the amount of lucites. They're getting, let's say they're getting babies. When you put it in the furnace, the lucites are getting babies, and then you have more and more and more lucites inside. Then the CT extends, it's going up to whatever, not to 12, it's going up to 18, 15, whatever. And then you have, after the 4th, 5th, 6th firing, you can have cracks. We are the only company we are able to produce ceramic without growing the amount of lucites. You can do 30 firings, whatever, there is no extension of the CTE. So we have a special technique how to do. So in our material, the lucites don't getting babies. We call it stabilized lucite system. That's called in our company like that. So that's a big advantage you have. If the metal fits to the ceramic, you won't have any problem. So that somebody asked me before I got some cracks or whatever. Could be one reason. When it happens after the, I don't know, 5th, 6th, whatever firing. Even the point is, sometimes you get the bridge is going to the patient and it's come back after 3 months or whatever, and the dentist said, I want to add some material or whatever. And then you do the firing and can be two reasons. One reason is wrong CTE, or the CTE is extending. The next is there's too much liquid inside. When the patient has the bridge in the mouth, it sucks a little bit liquid, the saliva, and the liquid which is in the porosities of the ceramic, we're talking about microscopic dimension. The porosities are full with liquid, and when you put it in the furnace, the liquid get from the liquid condition to the steam condition, and that means the volume extends tremendously. How much do you guess how much the volume of, I don't know, it's 1 liter or whatever, 1 liter of this liquid, when you put it in the steam condition, how many times it will be more? Give me a number. Any idea? No idea? No idea. Give me a number, say how many times.
Double.
Not bad. But then the steam engine wouldn't work. 3,000 times nearly. 3,000 times. That means if you have little water in your bridge and you put it in the furnace and it's getting from a liquid condition to the steam condition, the volume extends nearly 3,000 times. And that means you have pressure in the ceramic. And then the risk of chipping or whatever can be. So one reason can be the wrong CT, the second can be liquid inside. So if you get a bridge or ground back from your dentist to correct it a little bit, you have to dry, of course clean before, then you have to dry before you start the firing process. Round about 300 degrees, 15 minutes. Put it in the furnace, 300 degrees, 15 minutes, then you can start to add the ceramic. Very important. Okay. Yeah? Because no, sometimes it's happening, you get it from the dentist and put it in the furnace and shit. Okay. Good. I jump over a little bit, now I do this one. So, these things only have in Germany, I think, in India. Right? You never have this problem. What you can see, this is a metal bridge. You can see the metal here underneath, and you can see the black line. What do you think what this black stuff is? What is it? Chip off? Yes, but what's this black stuff? What's that? Yes, the gray one is the metal, right? But what's between metal and what's between the opaque? What do you think? What's in between?
I think cement.
No. The cement is underneath.
No, but
This is
Like oxide.
oxide. What you're doing, normally you're doing oxide firing, then with sandblasting, it depends which metal you're using, and then to remove these oxides. But the point is, when you're doing the oxide firing, you sandblast, then you steam clean it, then you apply your opaque. But the non-precious metals has a lot of ingredients which produce a lot of oxides. They're coming from underneath. Within every firing, when you do the opaque firing, when you do the dentine firing, when you're doing the second correction firing, when you're doing the glaze firing, whatever, always coming from underneath, under the ceramic, coming oxides. And if the oxide layer is getting too thick, it's like an isolation. And then things like this can happen. That means the oxide layer is too thick. It depends on the ingredients of your metal you're using. That's why some companies recommend doing oxide firing, some not. But always you have the problem if you have chipping or cracks or whatever, too many oxides. So how we can avoid this problem of this oxide production? You have to do it by a chemical way. Oxides is the result of a reaction between oxygen and between metal. So that's why we put this NP primer on. This NP primer avoids too many oxides. So you don't have problems like this. You don't have a thick layer of oxides. That's why we do it. So you have seen no oxide firing necessary because it's a chemical stuff. It had nothing to do with the color. It's a pure chemical stuff. If you have problem in your lab, whatever you're using, whatever ceramic or whatever, just try to use this. I promise you, normally you don't have a problem. If the casting is okay, of course. We can't do miracles, but if the drum is okay, you will have a good result. So, also chipping problem like that. What happens? As I told you, in the daily life, the same thing happens. When you have a metal which is covered by color or whatever, there's also the same process what we are doing within 10 minutes in the furnace happens in the daily life within, I don't know, 10 years or whatever. It's the same thing. That means between the tin, between the metal, and between the color, it's getting oxide more and more and more. We say rust, and then it looks like that, and then it chips off. And the same thing happens with your ceramic. Of course, within 10 minutes, and this is, I don't know, 10 years or whatever. So, this MP primer, what it's doing, you have to imagine, this is our metal. You have to think in microscopic dimension. Before, when you do casting or milling or whatever with your metal framework, you make it rough by sandblasting. Yeah? Because we need a rough surface to have a good bonding between opaque and between metal. And today, all the premixed opaques have a very high viscosity, like honey, let's say. And when you go with a brush over here, you have some gaps. The brush is going just on the surface, but not in the depth. That means some areas there is no wetting of this opaque, so you have, let's say, a little bit air bubbles underneath the opaque before you go to the furnace. Then you put, this is the opaque, this orange stuff, and this is the dentine. Then you have some oxygen in between the metal and between the opaque. And as I told you, every firing, you put energy in, you'll start a reaction between this oxygen, which is inside this oxide layering. So in this, the amount of oxides are growing. It's getting thicker underneath. You don't see that because you can't see it because you cover it by opaque. So it happens underneath. And that's the problem, the wetting and the amount of oxides. If you have problems in your lab with bubbles or with cracks, could be one of these behind. That means after a while you get a problem like this. Mostly when you're doing the glaze firing, it's coming up. When you have, there's too many oxide, too many reaction. So if you have this problem, take this stuff. I promise you, you don't have any more. So this is what we did. So now we make a little break again and doing the opaque, just to save time. Then I go on with the lecture. So there are some new guys now. We have to organize it somehow to make. You did MP Prime as well? No. You came late. Okay.
I'll give them models and.
So now it's your job to give the right card to the right person.
That's somebody from them can teach.
Okay. So the next step, what we are doing, we put opaque on. I think now we are so many people. Try with the camera. I go there and put the opaque on, and then it's your job. Okay. The carries the planes. Yeah. What we want to do today, we offer, of course, different levels, whatever you want. It depends more economically. That means only dentine and incisal adapted to the Vita shade guide. I think Vita shade guide is the most common used. Yeah. Yes. So if you get the information by your doctor A3 or whatever A2, just using dentine and incisal, and we have one material which is called to cover very thin areas. So we need, let's say, three powders. Then you get a perfect adapted to the Vita shade guide color. But if you want to do, I show you later. If you want to do very more things like effects like this,
characterizations.
Yes, characterizations. Then of course you need more colors. Yeah. So all the layering system is also on YouTube available. If you go to our homepage or this CD, yes. So of course all the possibilities are available. So if you want to have like this, first you have to put these colors, then you have to put, I will explain later, this value material, then you have to put all the colors, then you get this result. But for the daily job, I know you're under pressure, you have to get in the morning, finish in the evening, I know.
Shade matching.
Shade matching, and that's it. Okay. Good. As I said before, always very important to mix, especially for me when I'm in the plane, the turbines and the vibration. So it's the liquid is on top. It's very important always to mix it. You can see, yes. So it's very important to mix it before applying. We can make 2 layers or 1 layer. It depends a little bit. Sometimes you have a good day, one is enough. Sometimes you have a bad day. Shit happens. I'm using this. Oh, where's my brown? Can you bring?
Yes. उसको ला दे यार ट्रे। वो बड़ा होगा।
क्या चीज़ ट्रे?
और सबसे बड़ा।
But the pin, this one and the pin, you can take.
He's having.
Oh, I need here. Thanks. When you're using this, have a green brush. Very important. No water on. No water. No water. No? Not dilute with water. Never. If it's necessary, normally it's not necessary to dilute, but if using paste opaque liquid, paste opaque liquid, but normally
To dilute it.
Yes, but normally don't do it, because when you dilute it 500 times, there's only liquid inside, but no power,
No paste.
no paste. Yeah. Here it's A2. I have A2.
Yeah.
But if you A3 also have, I think.
Yeah.
You see, it's it's no color.
Yeah.
It's just chemical stuff.
After this firing, it's necessary second layer on that or not?
It depends. when you see some gray color coming through the opaque, you have to do a second.
Okay.
If not, it's unnecessary. It's just opaque only is to cover the black metal.
Black side.
So you have to see, you have to check. Sometimes, if a good day, it works, sometimes not. Okay, it's your job. Well, it's interesting for industrial production, but not for the normal people, whatever. So that's how the framework is made. You can see it looks a little bit rough on the surface, but because that's why it's layer by layer by layer. The advantage is you can do every shape, whatever you can do, undercut, you can do everything by this system. But what you can't see on the picture, you have always these supports there, and they have to be taken off before you can put it on a model, but it's another story. So that's just to explain how the grounds are made. Okay, so now let's talk a little bit about coloring. Yes, I'm thinking about the time. Okay, we talked before, we talked about metal. Now we're talking, just give you an idea about the zirconia, the 750. You remember the metal one has the red lids and the zirconia has the green lids. What you can see here is adhesive. The difference between metal and the difference between zirconia, metal has to be a rough surface to get a fitting, to get a bonding. The bonding on metal is depending on the roughness, it's depending on the oxide, but not too many oxides, that's a problem which we talked before. And the tensile, that means the shrinkage. When you put the crown with the ceramic on it in the furnace, both material extends during heating up. When it's cooling down, it shrinks. So it shrinks on the metal. It's, but if it's too much, you get cracks. So that's why you have to adapt the CTE to the base material. On zirconia, it's a different story. The bonding or the fitting is, you can imagine you have two glass plates. Normally they drop off. If you put some water, put some more, a little bit. Yes, it's the same effect you have. So it's different. The quality of the bond. Thank you. This one. The quality of the bonding, the smoother the better it is. The opposite of metal. I don't want to go too deep in the physical background. The point is, the lower the quality of the milling, the worse the fitting is. Or the other way, normally after what is it called, firing, you have a smooth surface like this, and when you do grinding or milling on the surface, it looks on the microscopic dimension looks like this. This is 1 micron, you know, you can see this is the size of 1 micron. We're talking about microscope. So the more rough it is, the worse it is. Now you can see it better. That's the normal structure. Never sandblast zirconia, never. If you produce sandblasting, if you do sandblasting, the surface looks like that. Then you have to repair before you're doing the ceramic. You can see.
कहने का मतलब sandblasting नहीं करनी चाहिए zirconia में.
Then you destroy the surface. Sometimes it's necessary to grind, you have no space, or it's too long or whatever. Then you have to grind, and then it looks like this. Of course, then you have to repair, or if you get a low milling quality, if this is a very bad quality, this one, you have to get the stripes, because the cheaper, the lower the quality. And then you have to apply this adhesive. It's the same idea behind like the NP primer for metal. This is for zirconia, the same thinking behind. And after firing, it looks like this, and after firing, you can see it's very smooth, very light glass, shiny. And then you have a very good bonding. Then you can put your ceramic on, no problem at all.
Which adhesive is this? What is the name of the adhesive?
Come.
Adhesive of the name of this adhesive.
Adhesive is called adhesive.
Okay.
I show you. It's a different story. This has all the ceramic materials has to go for firing the heat in the furnace. And the light curing materials, you can't do that, otherwise you get just nothing left, carbon. Okay, so talking about the coloring. Mostly you see nice pictures in every advertising wherever, but mostly you don't have a light in the background. So the only thing we can see is the reflection. The normal light, like the big one, like a very strong one like that, or the screen on the ceiling or whatever, the white light is a mixture of different wavelengths. That means the white light is a mixture of red, blue, orange, green, whatever, and the wavelengths are reflected in different depths of the teeth. That means our own teeth, our living teeth, producing proteins. That means the color is changing during the day. When you're in the morning or in the evening, you have more reddish particles in the sun. In the afternoon, you have more blue. Our own teeth are adapted to this, but artificial teeth need special chemical stuff to adapt this. If you have an incisal, one is your own and the other one is artificial, then you need a special technique to adapt this problem. Or be using that for fluorescence, but fluorescence has to be treated very carefully. If you have too much fluorescence and some artificial light, a discotheque or whatever, this black light you see whitish. So it has to be on the right position, this fluorescent material. Yes, this is the fluorescence. What you can see, if you have the fluorescence on the surface, as I told you, it's getting whitish in some light conditions. But if you have it a little bit under, let's say, under the incisal material, then you have a very natural appearance. And so our materials have different amounts of fluorescence inside. And another story is, if you have done your crown and bridge, you have done the first firing, of course you have a shrinkage. Every ceramic is shrinking. You have to correct it with a second firing. If you do the second firing only with transfer, with pure transfer material, it looks nice on your table in the lab, but in the mouth it looks gray. You can imagine why. Have anybody an idea? Why it looks nice on the light, everything is fine. You bring it to the dentist put it in the mouth, the patient says, oh, it's great. Why? Any idea? Remember the first picture I showed you. You remember these wires, these glass fibers. It's dark in our mouth, and you have this transparent material is nothing else than a glass fiber. You have the darkness in the mouth, it's guided to the labial area of the teeth. When you do the second firing only with transparent material, you're putting a light wire on top, and then to bring the darkness from the mouth, from the backside, to the labial area. That's why it looks on the bench nice, but in the mouth it looks gray. So therefore we have also a solution. It's called enhancer. I come up to the where's the material, which can be used for the second firing all over. Wherever you want, you can extend the incisal. It's necessary to extend 0.5 millimeter or make more volume or whatever. Just put it all over this. So you need only 4 materials. You can do everything.
Enhancer.
Enhancer. Yes.
It's a 20 gram pack. It's a shade wise.
We have shade wise and we have neutral as well. Okay. Yes. So we have normally have the 4 families.
zirconia जो megapascal जो capacity weight जो होती है इसकी megapascal is the strength zirconia
Strength in the word.
Strength.
Megapascal strength.
Zirconia, the ceramic or the framework?
1350
Ceramic.
beta 1300 in a 50
350.
okay और ये zirconia?
It's about 1200, it depends a little bit. Zirconia is about 1200, 1100. It depends on the transparency. Because the more transparent the zirconia is, the lower is the stability, the lower is the hardness. So that depends, because it's depending on the size of the quartz. But the hardness is not an important thing if you decide this or that ceramic. Everybody is talking about hardness. That's not the point. It's the elasticity, it's the abrasion, it's the breakage stability, it's a lot of components. The hardness is not. If the hardness would be very important, all the tires on the car should be hard, but it doesn't work. It's the same story, you know. Okay, so talking about this fluorescent, I don't want to go too deep in the layering system. This is, we call it metric system. This is a high-end system. We don't have the time. We are too many people today. As I showed you at the beginning, we can do everything. But today we do economical layering. So I go on a little bit faster. Yes, let me check. Okay, so that's enough for this. Otherwise, we don't have the time. The second point is, of course, implants are getting more and more, and we also offer for all systems, for metal ceramic, for silicone ceramic, as well for the signum later, we offer a complete set with a gum material, so all shades can be made. A really bright gum or dark gum, or in some ethnic people have really purple gum, really dark purple. It's also possible to make.
How can we identify your gum shades are 1, 2, 3, 4?
I have a shade guide.
You have shade guide.
Yeah.
ये सूरज ये तो नहीं आता ना तो ये रेडी कर लेंगे पूरा
No, the point is the reason behind this. I don't know why. In former times it was very fashionable to make this, to get a tip. And I was trained, it's crazy. I know it's crazy, but I did it for a long time. So that's why I don't use these liquids.
Okay.
But it's stupid. I trained myself to avoid it, but that's why I'm using water. So. some if you want to have in some areas some special colors or whatever. But today I'm using only 3 because I was asked to make only 3 colors. Yes. So, but we have the option. We can have the option. So also I'm using this if you have in the incisal area, mostly you have not enough space in the labial area. So you can see the border between your coping and the incisal area. Then you can use it, I do it later on the board. You can use it incisal, a very thin layer of this to cover this border with this ingreaser. Then you don't have the problem with seeing the framework underneath. The next step what I'm using is dentine. Okay, normally when it's a real work, I check the occlusion indenting because you have the shrinkage. So I put it in the articulator or whatever, check the height of the occlusion, and then I add in sisal material on top, but not checking the occlusion anymore because you have to make it a little bit bigger because the shrinkage. Okay, so normally I remove it now put the approximal contact point, put in the furnace. It's your job.
Oh, they don't.
you can go on with any second firing. We have a correction material which can be used when you're doing now the glaze. When you're doing the glaze firing, you can correct with this material as well in one firing process. So if you need some apoximal contact or some occlusal contact or whatever, we have this called COR, that means correction material. The firing temperature is around about 30 degrees lower. But you can mix it with whatever you want. You can mix it with opaque, you can mix it with incisal, you can mix it with everything. That decreases the firing temperature. Then you can add a cusp or apoximal contact or whatever you need. And then you can also do the glaze firing in one. That's one solution. If you're doing a big bridge and you need, I don't know, you need more volume, more interdental, whatever, we have this enhancer I told you before. And with this enhancer you can do the correction all in one. You don't have to use dentin, or you don't have to use incisal, or you don't have to use others. Just put all over where it's necessary, and you can do it all with one firing for the correction. That's the next step. Then we have to do the glaze firing. Today we are a little bit short in time to do a second firing. I think we don't have the time today because I want to demonstrate signal when my plane is going around about, I don't know, 6 o'clock or something like this. Well, I don't know, can you see this? Okay, I do the fissures with some, you can grind this material with carbide bursts. That's a big difference. Try some materials to grind with carbide bursts. You asked about the hardness before. The quality of a ceramic is not depending on the hardness. The quality is a lot of things I told you in the morning. It's abrasion stability, it's wear resistance, it's elasticity, and all the things. Okay? So you can use carbide bursted for no problem at all. And also, hey, can you do phoning outside, please? You can also use to polish pumice. You can do it by rubber first. I demonstrate you just to polishing. I don't do the glaze firing now, I just polishing. Because I have no steam cleaner, I have nothing in here. So I just want to show you to polish this material. It's a big difference if you polish this one. I just do only a labial area just to demonstrate. First with the rubber and the second with the diamond polishing paste, and then you have a really nice shining. Normally it's not necessary to make a glaze firing, but in the fissures you need. But if you have to correct something or whatever, you can use polishing. I'll do that now just to demonstrate. I hope you can see that. High speed.
It is 3000 RPM, high speed.
High speed. For polishing you need a strong machine. That's a little bit
It is a clinical micro motor, I think.
I know, yeah, it's just for correction. That's okay to carry this. That's fine. Of course, it's only a demonstration. You see. This material can be polished very easily. I'm using these acrylic brushes. You know this acrylic brushes? It's acrylic and diamond paste.
Which company is this? Diamond paste?
Kulzer. But very easy polish with pumice. Very fast, a big machine. That's it. The point is, I have polishing paste now. I can do the glaze firing because I have no chance to remove it by steam cleaner. So when I put the paste in the furnace, I have black dots. I can't clean it here. Or I tried, or let me try with...
Lunch is ready otherwise. If they can go for the lunch right away also, and we can wait for half an hour.
ये नीचे लिख देना फॉर PFM और एक कोरिया का भी कर लेना लाइट आ रही है
Okay, I do the firing.
यार
And
उसकी है पता नहीं वो
where it is. Give me the tray.
उसमें फाइल प्रोग्राम दे देगा ना सबको